Hello, welcome to lecture 36. This is the 12th week of the Law and Economics. Because the whole semester is 15 week, and then the last week would be for the final kind of sum up and assignment kind of thing. So I plan to do the lecture for 14 weeks, and the last week is for whatever assignment or something. So we have basically 2.5 week left as long as this online lecture is concerned. So if you have reached this point, you are going to have only 2.5 weeks left. Okay, cheer up. Okay, the end is very near. Okay, today I'm going to, by the way, everybody, I hope, remember that we are in the middle of tort law. And in this tort law, which mainly deals with accident, we want the people to be properly precautious. In order to do that, you remember strict liability and negligence are two big alternative rules, and we are going to do that through calculation by graph. I already show you that. Okay, let's go back. Already show you that strict liability, the social cost would be same as the cost of injurer. So injurer minimize its cost, which would be same as minimizing social cost. Therefore, automatically, the optimal precaution level X star would be achieved. The only goal in the tort law is making people choose X star, which is the proper optimal level of precaution. Second, if the negligence rule is the name of the rule, once again, the graph would not look smooth anymore, because if the injurer is careful enough, it is now responsible for the damage from accident. So it drops suddenly at X star, therefore X star would be chosen. Now, we are going to do that, the same thing, but this time not by the graph, but by calculations. In these calculations, for the first time in Law and Economics this course, we are doing calculation. Basically, if you have taken the mathematics for economists, or if you still remember the calculus that you have learned in the high school days, no problem. Okay, that's just high school level basic, not advanced, basic high school level differentiation. Why do we need differentiation? We are minimizing the cost, whether it's a social cost or individual cost, we are minimizing it. And differentiation is a very, very useful tool, actually the most useful tool, doing the maximization or minimization. Why? At the maximum point, at the top of the mountain, the slope of the mountain, because differentiation is basically measuring the slope of the curve. When curve hits the top, at the top, the curve's slope would be 0. If it's minimum like this, at the bottom, the slope is also 0. So by finding out the slope point X, where the differentiation value would be 0, we can find out minimizing point. Okay? It was very simple, but I thought that many of you already knew why we need differentiation and set it 0 in order to find out the minimizing point. Once again, differentiation is slope of curve. And the only function I want to use here is this kind of function. Fx is x powered by n. x powered by 1, 2, 3, something like that. So when you differentiate fxn, differentiate fx by x, n would jump out like this, and it's powered by n minus 1 instead of n. So if you differentiate x3, then it will be 3x2, something like that. Once again, I hope you remember that. You must have learned it. Just a little bit of twist I want to remind you is that this x value can be negative. Like if x is negative 1 powered by negative 1, it means 1 over x. Okay? If x is powered by negative 2, it's 1 over x2, something like that. What if we differentiate this, x powered by negative 1, or 1 over x? Same rule. The minus x1 jumps out like this, and the x powered by minus 1 would be x powered by minus 2, because n is minus 1, so it's minus 2, which means x powered by 2, 1 over x powered by 2. That is x powered by minus 2. Okay? So if x is powered by minus n, it's 1 over x powered by n. And differentiated, this n jumps out, minus n jumps out, that's why it's minus n. And n is 1 over minus n powered by, x powered by n plus 1, like this. Okay? Please have a look. You might have forgotten this, but then, go through your high school differentiation book or go through the first year mathematics for the economist book, then it'll come to you pretty soon. Maximum 10 minutes, you'll remember it. Okay, so that's up to you. Numerical example. In order to understand it better, I will give a specific number, numerical number for W, A, and P. I will set W equal 1, A equal 10 powered by 6. So 10 powered by 6 would be 1 million. So if there's an accident, you're losing $1 million, something like that. And the probability of accident is 1 over 1 plus X. This is because if you add up everything, then it'll be 1. And it's between when x equals 0, it's 1, which means if there's no precaution whatsoever, you are totally, completely careless, which is x equals 0, then the probability of the accident would be 1 by assumption. And if you are extremely cautious, x goes to infinity, it's 1 over infinity, so the probability of accident would be 0. Something like that. Okay, in this case, the social cost can be rewritten x plus 10 powered by 6 over 1 plus x. Where can we find the minimization point of social cost? If we differentiate social cost by x, it will be x1, and the second part, this 1 over 1 plus x here, it's like powered by negative 1. That's why we have negative here. And then because negative 1 jumps out, it becomes negative 2. So 1 plus x powered by 2. Okay? So this is the first order condition. And if any x satisfies this, that x would be the optimal precaution level, which minimizes the whole social cost. Okay? How come we came from social cost, the social cost differentiate by x? I already mentioned this. This is why we get from here to here. So, take your time. And from this red square, if we rearrange it, because 1 minus this would be 0, so 1 equal this, and 1 plus x power by 2 can be here. So 1 plus x star means whatever satisfies this, the x would be the optimal x. That's why I denoted as x power by star, x star. 1 plus x star whole thing power by 2 should be equal to 10 power by 6. We can rewrite 1 plus x star should be 10 power by 3, which means 1000. So x star should be 1000 minus 1, that is 999. So what's the meaning of 999? I don't know, but this is how you find out the optimal level of precaution if this numerical example is given to you in the exam. Okay, understand? Once again, this calculation is very important with this specific probability given to you. That this is very easy to handle kind of probability. All other probabilities are not so easy. So anyway, you have to keep in mind. So if you go back, we find out in the social cost graph, this point and this x star, which minimize the social cost, the whole thing, is the optimal level. So we found out optimal precaution level by this way if we use the graph. But if we use the calculation, this is how you find out. Okay, same thing. The graph and this numerical example are the same thing, but then the numerical example you have to calculate. And of course, if the numbers are given, numerical example gives us a more accurate numbers. Okay, once again, we do the same thing. What same thing? Okay, sorry, I'm going back. Under strict liability, I told you that the cost of injurer would be same as the cost of social cost. So that is why the injurer would choose what is the socially best, socially optimal precaution level. Let's look at that. Here, once again, the cost of injurer, because strict liability means if there is any accident, whether the injured was careful or not careful, the injured should be totally responsible for the damage by accident A. Okay, this is multiple dot. Okay, so that is why the injured's cost would be same as the social cost itself, because injured is totally responsible for A. So the cost of being careful is individuals. You can ask others to bear that. What about the expected cost from accident? The judge said, under strict liability, it's your responsibility, injurer. So these are the costs of injury. Because the CI is same as social cost, the injurer will calculate. The calculation would be exactly same as what we did. So he goes through all this, not because it's socially optimal, but because it's individually optimal for the injurer under strict liability. And probably, or must be, he found out x star equal 999 would be the best choice for him in order to minimize the cost. So he will choose x star as the society and economists hoped for. So it's going to be efficient. What about negligence rule? This would be a little bit different story. Negligence rule, the cost of injurer would be same as social cost if he or she is not careful. X is less than X star. X is actually what the injurer would choose. The carefulness is less than optimal, and then there is an accident. You're not going to be charged for not so careful. But if you have an accident and you were not careful, then you are totally responsible for the damage A under negligence rule. But if you were more than enough careful, your carefulness is precaution is bigger than or equal to the optimal precaution level, then you are not responsible for A anymore. You are a driver. You abide by all the rules, speed limit, traffic signal, everything. Still there's an accident. But then the government say you didn't do anything wrong. So sorry for the victim. The government cannot ask the injurer to pay the victim the A. So this would be it. So it's the same as that. This one, two different functions, x bigger than x star, x less than x star. So here, we cannot differentiate because the graph is not smooth. However, obviously the injurer will choose x star as we have seen in the graph. So, this numerical example is not more complicated than the graphical example, except for that we have to do the differentiation a little bit, the first order condition for the minimization. However, by this, I show you how you can calculate the optimal precaution level and whatever the precaution level the injurer would select under strict liability rule or negligence rule. And the result would be, of course, naturally should be and is same as what we did graphically in the next lecture, lecture 35. So this is the end of lecture 36, and we are going to continue in lecture 37, and we are in the middle of week 12 of this law in economics.